Imagine drinking satellite imagery from a fire hose. You are thirsty, but you can't manage to drink it all. And even your multi-terabyte mass storage systems fill up far too quickly. You need to delete old images to make way for the latest up-to-date imagery that the fire hose will deliver tomorrow. But what if deleting old imagery leaves you with blind spots on the globe? Murphy's Law says those blind spots will be critical to mission planning the second you delete them. My name is Paul Brewer, and I'm Director of Image Analytics with DZYNE Technologies Incorporated. And today I have the opportunity to tell you about a SBIR program called Smart Caching of Imagery for Carry-On System, or SCICOS, that applies advanced artificial intelligence to tame the imagery fire hose and optimize global satellite imagery assets to give Tomahawk missile mission planners the reference images that they need when they need them. DZYNE Technologies just celebrated its 10-year anniversary. In a single decade, we have grown from a 3-person startup to a 175-person company with employees based in 15 states and 80,000 square feet of facility footprint that house our R&D and prototyping, manufacturing, and software engineering organizations. Our autonomy and analytics software group, which I manage, develops advanced full motion video, satellite analytics, and autonomy solutions that are the brains of our aircraft as well as other systems in the DoD and intelligence communities. DZYNE's mission is simple: create innovative, intelligent, autonomous aircraft. We have developed aircraft that range from the small, Group 1 hand-launched and tube-launchable fixed-wing aircraft all the way up to heavy-lift multi-rotors that operate in autonomous counter-UAS applications to the very large. We have achieved over 35,000 combat hours on our Group 4 and Group 5 long-endurance fixed-wing ISR aircraft. Our LEAP aircraft has greater than 30 hours of endurance and is a fully autonomous system that is 5 times lower in cost than the MQ-1C Gray Eagle and achieves in excess of 70,000 hours of operations between failure. The original topic associated with this effort is titled Relevant Image Mosaic Image Management Algorithm Development, and the objective is to develop a more sophisticated imagery storage management capability for intelligence, surveillance, reconnaissance, and remote sensing systems than currently exist, with focus on the management of imagery from various platforms while also expanding capability to address still frame imagery from tactical sources. In short, the Navy is on the receiving end of a fire hose of satellite image assets and limited ability to retain those assets for use in mission planning activities. Currently, imagery exploitation systems that are directly connected to the fire hose quickly fill their available storage and either fail or begin dumping imagery using some very simplistic management scheme. This scheme is typically a first in, first out approach. Just delete the old images. The quality of imagery thus held at any point represents the result of this default imagery dumping strategy that it does the intended needs and mission success of the system operator. I refer to this as the you get what you get and don't get upset approach to image asset management. By way of an example, suppose the current image library in a certain region consists of 814 high-resolution satellite images. Some areas might have many images looking at the same spot of the globe, while other areas may have no coverage in the current library. The bottom images in this slide show that the FIFO strategy to image management results in large regions being completely unrepresented in the image library, which leaves the analyst blind. SCICOS applies a series of rules that lets the system declutter the image library of redundant imagery and maintain optimal image coverage. SCICOS enables the user to create and evolve retention strategies that meet the critical operational need. The SCICOS dashboard provides data retention statistics at a glance, and advanced analytics provide insight into the effectiveness of the image retention strategy that the user has created with the SCICOS tools. When it is in use, SCICOS recommends image sets for deletion and lets the user make the final decision to delete or to iterate on the retention strategy. During phase 1, we developed a software prototype that demonstrated image ranking by an initial rule set and processed and managed 5,000 unclassified images that weighed in at 3 terabytes of storage. During phase 2, we deployed a more mature version of SCICOS to the Washington Planning Center, where we demonstrated operation on a classified image set. We provide tools to enable the end user to create, evaluate, and evolve image persistence strategies and evolve the software framework to handle additional imagery sources such as PixDB. We managed to get our software installed and tested on site in spite of COVID-related headwinds that limited our access to WPC for large chunks of time. We have signed a technology transition agreement and are moving down the transition path. We also began work on a related SBIR called CASI, or Cloud Analytics of Satellite Imagery. This topic originated at DARPA and provides image content aware analytics to the SCICOS tool. So instead of retaining or discarding imagery solely based on image metadata, CASI uses advanced AI ML capabilities to assess the image itself. Does the image have excessive cloud cover? Delete it. Does the image contain buildings and roads that are mission relevant? Retain it. As I discussed earlier, the baseline image retention approach that we have to beat is a FIFO strategy, first in, first out. That is, just delete old images. We have demonstrated that we can process 150,000 images, that is 50 terabytes of imagery, in just 5 minutes, and rapidly declutter duplicative imagery, prioritize imagery based on a rule set that is iteratively developed by the user, and can clear out the image archive by 2/3 to accommodate the latest up-to-date imagery that the fire hose will provide tomorrow and the next day. It is a bit of a Sisyphean task, and now SCICOS provides the user advanced AI tools that push that rock back up the hill and focus on faster and more robust mission planning without worrying about the grunt work of managing the image library. Faster mission planning means greater lethality for our users. In order to cross the dreaded transition chasm, SCICOS and CASI must be put to use on classified data against operationally relevant missions. Our development path is currently sequenced ahead of the Tomahawk Missile Planning Center Program of Record schedule, and we are on track for 2022 TMPC integration following unit testing in the integration lab. We are pursuing a transition to fleet model via integration into the Tomahawk mission planning workflow and have identified additional transition potential in the Tomahawk planning organizations in other branches and with partner countries. In addition, the SCICOS image management capability is relevant to many other DoD, IC, and industry applications that require the use of significant archives of satellite imagery assets. In summary, SCICOS and CASI software scans big data satellite imagery archives daily to enable users to move past the current FIFO deletion strategy and implement optimal AI-based strategies that will give them the imagery they need when they need it and let the user focus on mission planning instead of image deletion. We are well on our way through verification and validation and integration into the Tomahawk Mission Planning Center software framework. Commercial applications include satellite image management and analytics for satellite constellation providers, as well as end users in the land survey, housing, and risk management markets. Thank you for your attention. Please feel free to contact me at pbrewer@dzyntech.com to further discuss the capability and any use cases or requirements you may have. You can also see more of DZYNE's innovative, intelligent, autonomous aircraft at www.dzyntech.com.